Now, we will be balancing redox reaction using the aqueous medium. Using the aqueous medium. Using aqueous medium balancing method, it means we either balance in acidic medium or in basic medium. It's either you balance it in acidic medium or in basic what? Medium. That is why we call it aqueous medium method. So it's either it's balanced both in acidic or in what? Basic, depending on what the question is. And there are steps that are involved when balancing redox reaction using the aqueous medium. And the steps include one. The steps include 1. Divide the equation into 2 half reaction. Divide the equation into 2 half reaction equation. Divide the equation into 2 half reaction. That is, the first step is to divide it into redox. That is red or what? Ox. Red is reduction half cell or what? Oxidation half cell. 2. Balance each half reaction in the following sequence. Balance each half reaction in the following sequence. And what is the sequence? The sequence involves 1. Balance the elements other than hydrogen and oxygen. Number 1 is balance the elements other than hydrogen and oxygen. Balance the elements other than hydrogen and oxygen. 2. Balance oxygen atoms by adding water to the other side of the reaction. Balance oxygen atoms by adding water to the other side of the reaction. 3. Balance hydrogen by adding hydrogen ion to the deficient side of the equation. Number 2 is to add water. And number 3 is to add hydrogen ion to the deficient side. Deficient side, that is the side that don't have much of hydrogen. The deficient side of the reaction. And number 4 is balance the charges. Balance the charges by adding electrons to the appropriate side. Number 4 is balance the charges by adding the electrons to the appropriate side of the equation. It is important for us to follow the sequence step. It is very important for us to what? Follow the sequence step. I will repeat the sequence step again. The first step is to divide the reaction into 2 half reaction. That is redox and what? Oxidation half reaction. 2 is to add water to the other side of the reaction. 3 is to add hydrogen ion to the deficient side. And 4 is to add electrons, that is charges, at the appropriate side. When you have done this sequence, then you follow the second rule, which is to balance the electrons in both half reactions. Balance the electrons in both half reactions by multiplying through by appropriate values when necessary. By multiplying through by appropriate values when necessary. And number 4 will be add both half reaction equation. Add both half reaction equations and simplify by cancelling out species that are common to both sides. And simplify by cancelling out species that are common to both sides. I said we should add both half reactions equations and simplify by cancelling out species that are common to both sides. And lastly, check to make sure all atoms are charges are balanced. Check to make sure all atoms and charges are what? Balanced. Are balanced. So we are going to take example of that, how to balance such equation. We are going to take example. Okay, so we are going to look at these two examples. We'll use this first example. We use it for acidic. We balance in acidic medium. And the second example, we are going to balance in basic medium. So we are going to balance in the two medium so that we understand the aqueous medium method. So when we bring out number 1, we said manganese plus the oxalic ion to give us manganese in oxidation 2 plus CO2. Yeah. So the first thing is to indicate, like we said, the first step is to divide it into their half reaction. So how do you divide into their half reaction? You look at from manganese oxide to manganese and from oxalic to carbon-4 oxide. What has happened? From year to year, is it oxidation or reduction? We know the definition of reduction and we know the definition of oxidation. Reduction means loss of oxygen atoms, and oxidation means gain of oxygen atoms. So if you move from year to year, you see that manganese has lost its oxygen atom. So therefore, here we call it reduction. Why? Not just because it has lost oxygen atom. If you also move from -1 to +2, what has happened? There is a decrease in oxidation. Remember, in chemistry, negative means gain, but the oxidation number here is 1. So from 1, we gained 1 and we lost 2. So it means there is a decrease in the oxidation number. But moving from year to year, oxidation has occurred because the oxidation number has increased from what? The oxidation has occurred here because the product shows that carbon has gained what? Oxygen. So here is what? Oxidation, and here is reduction. And therefore this becomes a oxidizing agent, and this becomes what? The reducing agent. So you are going to write it into their half cell. First we bring out manganese, which is the reduction, to give us what? Manganese N2+. So we are first going to balance the half cell of this. And how do you balance? We said in balancing we use the sequence, the steps that are involved in the sequence. What are the steps involved in the sequence? One is to balance each element. Look at it. We have manganese here, 1, and we have manganese here. Now, but here we have oxygen, but we don't have oxygen at the product. So how do we balance oxygen? We said balance oxygen by adding water to the other side of the reaction. So it means we are going to add water. Then how many atoms of oxygen are here? We have 4. So it means we will put 4 so that we can have 4 moles of what? Oxygen. Now, the second step is to balance hydrogen by adding hydrogen ion to the deficient part of the equation. Are you seeing it now? So look at the reaction now. Where do we have deficiency of hydrogen atom? We have it at the reactant. So the instruction is that we should add hydrogen ion. So it means our new equation will be NaO4 plus hydrogen ion to give us Mn2 plus 4 molecules of water. So it means we are going to balance the hydrogen. And how do you balance? Here we have 8 hydrogen atoms because 4 times 2 will give us 8. So it means we are going to put 8 here so that we will have 8 hydrogen atoms. So have we balanced the atoms? You look at it. We have 1 manganese here, 1 manganese here. 8 atoms of hydrogen ion. We have 8 atoms of hydrogen atom. Oxygen is 4. Here, oxygen is also what? 4, because 4 times 1 will give us 4. So we have balanced the half cell. Now, the next step is to balance the ions, that is the electrons. How do you balance? You look at the electron here. The electron in this molecule is -1. The electron here is +8. -1 plus 8 will give us what? 7. To give us 7. Then you will come over to this place. Here is 2 plus. 2 plus. But this place is what? 0. Every neutral molecule has an oxidation number of what? 0. So what do? It means this reaction have to lost 5 electrons for it to be balanced, because it's a reduction, so it has to gain. So it means we are going to add 5 to the reactant part. So it becomes C4 minus. So this is the reduction half cell, and it is balanced. How do you know it is balanced? You look at the atoms. Manganese is 1. Manganese at the product is 1. Oxygen is 4. Oxygen at the product is also what? 4. Hydrogen is 8. Hydrogen here is 4 times 2, which is also what? 8. Then the ions, -1 plus 8 minus 5. Look at it. -1 plus 8 minus 5 will give us what? That will give us +2. Then over here is also what? +2. So the ions, the atoms of oxygen and hydrogen and every other element is balanced. So the next step is to go and balance the oxidation half cell. You balance the oxidation half cell. And follow the same process that you used in reduction. So what are the things that we oxidize? We have the oxalic ion to give us what? CO2. The oxalic ion to give us CO2. So in doing that, carbon, how many carbon is at the reactant? It is 2. How many carbon is here? It is 1. So you have to put 2. Such that when you say 2 times 1, will give us 2. Oxygen is 4. Oxygen here will be 2 times 2 equals to what? 4. So you see carbon is balanced, oxygen is balanced. Now the charges, is the charges balanced? You look at it. The charges here is -2. And like I always tell you, that the charges of a neutral molecule is always equal to what? 0. So this is equal to what? 0. So this reactant is -2, here is 0. We need to balance it. And how do you balance it? By adding electron to the product. And how many electrons? 2 electrons to the product. Because this is oxidation, you have to lost electron, and electron loss shows at the what? Product. So it means therefore that oxidation half reaction equation is balanced by 2 molecules of carbon, 2 molecules of carbon, 4 atoms of oxygen, 4 atoms of oxygen. The charges here is -2. The charges here is also -2. So the next step is to add the balanced red means reduction, to balanced what? Us, to form your redox reaction. And how do you add? You add by product to product, reactant to what? Reactant. All the reactants in the reduction half cell, add it to the reactant in the oxidation half cell. So we have MnO4 minus plus H plus 5E minus to give us plus C2O4 2 minus to give us Mn2 plus 4H2O plus 2CO2 plus 2E minus. So when we add, the common terms have to cancel out. So you look at it, which of them are the common terms? There is no common terms here. Since there is no common terms here, you simply do add it to equate all of them to form your redox reaction, plus 8H plus you, like I told you, that you will need to, if you look at the step, you will need to balance the charges with the appropriate values at both half reaction. You see the charges here is 2, but the charges in the reduction is what? 5. So how do you balance it? It means you will multiply the first one, which is the reduction half cell, by what? By 2. And you multiply the oxidation half cell by 5. And when you do that, you will now have 5 MnO4 minus 5 MnO4, sorry, not 5, 2, because you are multiplying by 2. That is, multiply this by 2 and multiply this by what? 5. So we have it as 2 ml, here will become 16 H plus, then 10 E minus plus 2 plus 5 C2O4 2 minus to give us 10 CO2 plus 2 Mn2 plus 8 H2O plus 10 E minus. When you have done this multiplication, you will now cancel out like terms. What are the like terms here? 10E minus will cancel out what? 10E minus. And you are left with what? 2 MnO4 minus plus 16H plus 5 C2O4 2 minus to give us 10 CO2 plus Mn 2 ml 2 plus 8 molecules of water. Then you now cross-check, because the last step said check to confirm that atoms and charges are equal. How many manganese do we have at the reactants? We have 2, which corresponds to the 2 at the products. Oxygen here will be 2 times 4, 8, plus 5 times 4, 20. So 28 oxygen atoms are present in the reactant. Then how many are present here? 10 times 2 is 20. 8 times 1 is 8. 20 plus 8 is what? 28. So oxygen is balanced. Now we go to carbon. 5 times 2 is 10. We have 10 times 1 is what? 10. So carbon is 10, 10 in each side. Then we go to hydrogen. Hydrogen here is what? 16. Hydrogen here is 8 times 2 equals to what? 16. So we have balanced that of hydrogen. Now the electrons. 2 minus 2 plus 16 minus 10, because 5 times 2 will give us minus 10. So when you press your calculator, you will have it to be what? You will have it to be 4 electrons. And over here, 2 times 2 is what? 4. So you see 4 electrons, 4 electrons. The electrons are also balanced. Thank you, and keep watching ChemTech, and subscribe, like, and share. Thank you.